Okay, hi everyone. Welcome to the Golang training. So before starting, I'll give my introduction. My name is Ashwini. I've been working with Josh since 7 years. So yeah, today I'll be your trainer. Before starting actual session, I would like to ask you guys, do you have any questions regarding yesterday's session that you want to discuss? If you have, you can paste it in the chat. We can discuss. If no, you can mention it as no. Okay. Okay, great then. Yeah, let's get started with today's session. Let me just hide this. Okay. So till now, it's not moving to next. Sorry guys, give me a minute. It's not moving to next slide. Are you guys able to see my next screen or not? Yeah, it's coming. Okay. So till now, we have looked at some basic Go programming. We learned about variables, how to define a variable in Go, how to initialize it, what are the different packages, how can we create our own custom package, what are the different data types Go supports, few data types like array, slice, maps, strings, etc. And then we covered pointers, methods, and interfaces. And then yesterday's session, I think you had error handling, panic and recover, context, and Go modules, right? So if you see all these topics, you must be finding that these are the topics which you already have in one or the other language, right? So what is that Go has different thing? So today we are going to learn something different about Go, which is different from other languages. So the first thing which we are going to learn is, you must have heard that Go is fast. So to make Go fast, we need to understand how Go is fast using concurrency and parallelism, how Go implements concurrency and parallelism using Goroutines and channels, what are the wait groups, what is select, syntax, and there are sync and mutexes, how these are used. So these are the topics we are going to learn today. Okay, so before going to going to concurrency and parallelism, let's understand what do you guys know about concurrency and parallelism. Can someone give me example of concurrency and parallelism? You can unmute yourself and tell. What do you guys know? You must have heard this term, right? In Java or C++, you must have heard this thing, parallelism or concurrency, right?
Running multiple instructions at the same time.
Running multiple instances. Sorry,
yeah, instructions at the same time.
Okay. What else? Do you think these are the same things, concurrency and parallelism, or is there any difference between them? You can give real-time example as well. Not in terms of programming. You can just give example in terms of real life example. Anyone? Okay, I'll give you an example. Okay, so you tell me whether it is concurrency, parallelism, or both are the same things. Let's say I'm watching a TV, and along with that I'm reading a book, or I'm eating something. So what is this? So I'm watching TV and reading book. Is this a concurrent action or parallel action I'm doing?
Parallelism.
Concurrent. Someone said concurrent. So what's the difference? Anyone?
So here we are not able to do both at the same time.
One task at a time.
Sorry, one time at a time. One task at a time.
No, more than one task. Multiple tasks at a time.
So that is what, parallelism or concurrent?
Parallelism.
Okay. Yeah, that is right. But there is little difference between both the things. So let's understand that. Concurrency is not same as parallelism. So these are two different things. Okay. So in the same example, which I mentioned, that we are watching a TV, along with we are reading a book or eating. So in this case, my eyes are watching TV and also reading a book, but they are not doing the same thing at the same time. So at the time you can watch at TV or you can look at the book, right? So that is nothing but a concurrency. And you are eating as well as you are watching. So your eyes and mouth are doing parallel things. They are doing same, like they are doing something at the same time. So that is nothing but a parallelism. Okay, is it clear? So the definition would be doing multiple things at the same time, that is concurrency, but doing things at the same instance of time, that is nothing but a parallelism. Is this clear to you guys? Okay, let's take one more example for the same. Okay, let's say we have a restaurant. The restaurant has two counters. One is for ordering, other is for collecting money. Okay, so let's say the one person is like gone out for some work. So there is only one person to handle both the counters. So what he has to do, he has to manage, he has to take order, and suddenly he has to switch to collection. So whenever there is long queue in front of collection, he had to move to collection part, right? So he has to do these things concurrently. So he cannot do both the things at the same time, parallelly. So this is nothing but a concurrency. Okay, if the other person is present, he is collecting collections, and the current person is collecting order, that is nothing but a parallelism. Okay, clear now? Okay, so this is our real-time example. What about in terms of like programming language or computers, how these are things implemented? So you must have heard term multi-threading, right? So whenever you listen these words, you must have like heard of multi-threading, right? Yes, multi-threading. So you must, all of you like multi-threading? Like, do you guys are proud of that you have done multi-threading and you're so much comfortable about it? Is it? Silence. Nobody says anything. So that's what happened. Yeah, that's right. Code is very extensive. So that was also my thought when I was not aware of Go language. So, but when I come across Go language, it made so easy. Okay, so let's see how Go makes it very easy. So when who are the creators of Golang? Who are the creators of Golang? Can someone answer? Rob Pike, one name. 3 persons are there. Ken Thompson, right? And there is one more person, Robert Grisman. Right. So when they were creating this Golang, so they, while like thinking about concurrency and parallelism, they went to the basics. They went to all the docs or papers they have in the 1970s. And they come up with one approach called as communicating sequential processes. So this was this paper was already there in 1978, but at that time, no one visualized that this could be our future. So what does this say? So this says, do not communicate by sharing memory. Instead, share memory by communicating. So does this sound complicated? Do not communicate by sharing memory. Instead, share memory by communicating. So whenever you go to some talks or you read some presentations about Go, you will find this line everywhere. Okay, so what does this mean? Let's understand that. Okay. So first line says, do not communicate by sharing memory. Let's understand this with the help of one example. Okay. Let's say we have a piggy bank. Piggy bank contains money. Okay. That piggy bank is kept on a table. Okay. So that piggy bank also has a lock which can be opened with the help of this key. Till now got it? So there is a table. On table we have this piggy bank. Okay. And piggy bank can be opened with the help of this key. Okay. So there are 5 people equidistant from this table. They want to withdraw or add money to this piggy bank. Okay. So what they will do is, whenever there is a key on the table, so all of them will rush towards table to get the key. One of them will get it. So here, this key is nothing but a shared resource. Okay, but this key can be accessed by only one person. So one will get, other will remain idle, or they will do their task. Okay. So whenever one person gets this key, he will open this piggy bank, add or withdraw money, and once he is done with his job, he will keep that key on the same table. Got it? Someone say yes or no, if till this scenario is clear or not. Okay. Okay. So so whenever this key is kept back on the table, so other people will rush. So this is nothing but a race condition. So everyone is racing towards this key, and this key is a shared resource. So let's say if someone forgets to lock this piggy bank, so this could happen, right? So that can cause many problems. So this is how the earlier programming language used to implement multi-threading. But this was causing few problems like memory management issues or like unlocking issues. And you must have seen segmentation fault many times, right? And also sometimes you must have observed that you're writing some multi-threading programming and your program suddenly gets hanged, right? So these were the few problems with the current approach. So the creators of Go, they thought it differently and they implemented another approach, which is nothing but instead share memory by communicating. So in the earlier example, we saw do not communicate by sharing memory. So this is nothing but a memory which is being shared by other 5 people. So what Golang suggests is do not communicate by sharing memory, but share memory by communicating. So how this works? So instead of this key, now what Go does is, the way it provides is, instead of holding having this key, so the person, let's say the person who keeps this piggy bank on the table is a creator of this piggy bank. Let's call it as main thread. Okay, what he will do is, he will not keep this piggy bank on the table. He will keep that in his hand. He will remove money or add money to this piggy bank. And once his work is done, what he will do is, he will hold this piggy bank out and he will wait till other person takes it. So this way he is blocked till other person takes it. So when other people see that the person is holding this piggy bank to take someone out, so they will rush towards it and one of them will get it. So once one of the person will get the piggy bank, and this person will be free to do his own operations. So this is how Go implements it. So this is the approach Go uses. So I told in the topics list that we have Go routines and channels. So this is the way channels communicate with each other. So we'll see this in the future slides, but this is the basic principle you should know. So that's why I wanted to let you know, guys. Okay, is this clear? Okay. Okay, let's go to the actual implementation part. So, so Go provides these Go routines for multi-threading. So how these are different from the original threads? Let's see first that. So which makes these Go routines faster than more other languages. Okay, so let's first see threads. So threads are nothing but the existing way in which other programming language implements multi-threading. Okay, these threads are nothing but managed by operating system. Operating system creates thread, schedules, operations, and context switch. So everything is done by operating system. So those were managed by OS. So it was having size of 1 memory, 1 MB. So it used to take, it takes actually in other programming languages around 1 MB, minimum of 1 MB of memory size to run. So compared to this, Go routine is managed by its own Go runtime. Go runtime is nothing but a program written in Go. Okay, we'll see this in the further slides, what it is, how it works. And the size of the memory size taken by Go routines are 2 KB, which is much lighter than this operating system threads, which allows us to launch multiple Go routines, which will make our program faster. So this is why Go routines are faster than normal multi-threading operations in other programming languages. Okay, is this clear? Okay, so this is the basic concept of Go. No, and what is the question? Chandu, Chegrolu, any question? Why faster? Because we'll learn internal working of Go routine, which is using Go runtime. But if you see the memory taken by this Go routine is very less, so you will be able to launch multiple threads. So in the memory size of 1 MB, so there, if let's say you have thousands of threads, thousands of actions you want to perform simultaneously. Okay, so that will take 1000 memory byte, so which will be slower than this 2000 KB, isn't it? Right? Am I right or not? If you are taking less memory, that means your operations are going to be faster. Okay. Okay. So let's move ahead. Let's see how Go routines are defined in, like, used in Golang. So it is really easy to implement Go routines in Golang. You just need to append Go keyword in front of your function name. So unlike other languages, like you have to implement some other class, in Go it is really easy. You just need to append Go keyword, nothing else you have to do. Let's just see one example. Okay. Okay, can you guys see my screen? Is this font visible to you guys? Is this fine now?
Can you zoom in a little bit?
Okay, I'm doing it, but now?
Yeah, it's fine.
Okay. So this is you're familiar with this syntax, right, till now? Can someone predict the output for this program? What will be the output? Nobody knows the output. 5 hellos followed by 5 worlds. Correct. So let's just run it. So this will print 5 times hello, 5 times world. So let's spawn a go routine. Okay. We just need to append go keyword in front of it. Let's run it. What happens? Let's see. So what happens? It just printed word. Okay. So why this has happened? Because so this is a main function we are running. So when we add this go keyword to a function, so this will create another thread. This will just launch another thread and it will continue execution of its own thread. So this is just complete. It doesn't know about anything about this new thread that we launched. So it just exited. Okay. So if I want to see like what is happening here, how can I do it? So I can just add a sleep time. Okay. Let us see. I'll just add second. Okay. Let's see now what happens. See, hello has printed, but the sequence is not fixed. If I run once again, yeah. So this is how this is happening in concurrently. So if you see, first it has printed world here, but in the second case, so the sequence is not fixed. Right now it's showing what initially. Sometimes like sequence gets changed. Yeah. So this depends on all. Yeah. Now it changed. So this is how we obtain concurrency in Go using this Go keyword. So you can also define this instead of named function, you can use anonymous function as well. Okay, so anonymous function is nothing but a function without name. So you just need to call this function. Okay, so let's just write something inside it. We can launch as many Go routines we want. Okay, so let's just print. Okay, we cannot guarantee the sequence because this is the concurrency. This can happen in any sequence. Okay. Is this clear? So how to define Go routines in Go? Why adding sleep time lead to doubt? Because we want to stop this main thread because main thread doesn't know anything about this thread, right? So this will just exit whenever it works is over. Okay, so that's why we added so that it should let other thread execute. This was executing, but we were not able to see it. If we stop it, so then we'll be able to see it. So this is the main thread we are running. Okay. Why it is slower than which one? No, first it like this will first launch one thread, then it will start execution of this. So this there are chances that main thread will execute first and then this, but it is also not guaranteed because this is a concurrency. So after launching to execute, there should be slight time taken, right?
No, in previous slide, you were telling that Go routines are faster than the main threads.
No,
Like-
no, not main threads. So main thread is also a Go routine. Okay. That is faster than other programming languages thread, which are used by other programming languages. So Go uses something different approach Go has followed. So we'll see that in the coming slides. So how it implements like Go routines. Okay, I'll just remove it. This will not run because main thread will do its job and then it will start execution of another.
So is the main routine, I mean, main Go routines always faster than the other Go routines?
Yeah, sometimes because I told you like this is the current thread. So this is getting launched and then executed, right? So there is slight time it will take. This will not work. So we need to add time. There are different ways to do it. This is just a hard-coded way to add time slip. This is not the right way. We'll see ahead what is the correct way to like wait for other Goroutines to execute, like exit. Okay.
So in case if the main Goroutine has some computation and that may take some time, so will the different thread get executed before the main routine without giving the sleep time?
Without this,
Yes, like some computation like that if in the main Goroutine
add-
itself.
I'll just add 2 + 4. Is that you mean?
Yes.
You mean? Print it out. Let's just print it out. Till it does computation, do you mean is this getting executed or not?
Yes.
Let's see. Declare but not yet. Sorry, not mistake. No, this will not, because this takes some slight time to execute. Okay, so we need to wait for this Goroutine to like exit some or the other way. So one way was to add slip. So we'll say some other ways, which are the correct ways to be used going forward. Okay.
But like we added sleep so that this output might come out, but but we added the sleep after the execution of the greeter function in main. So how did it get executed before at times or sometimes? If removing sleep has no output, that should mean that every time main is being executed faster.
Yeah, we
Then
need
why
to wait
putting
for the
sleep?
output from other thread, right? So we are not sure when the other thread is going to. I mean main thread doesn't know when other thread is going to return. So it needs to wait for other thread to exit, right? So there are different ways to wait for it, to let other thread execute, like exit.
Yeah, that is true. But if it's not fixed which order it is, then if you remove sleep, then sometimes the output should occur, sometimes it should not, right? But like because the sleep was after this,
Yeah, we are doing like this operation is really faster. Let's just add some for loop which executes, let's say, some more time. Okay, let's just try that out. We'll just add larger. Okay, this is a sequential line we are going to execute.
Please don't do that line. We won't be able to see, like we will have to find.
After the for loop, put just one statement maybe.
Yeah,
Don't
I'll do
put
that as well.
because that will be too many prints. Yeah.
Okay, you just want this.
Just put something like any random stuff in it. Yeah.
Okay, done with. So this is really fast. So this takes really less time than this start execution.
Can we put some computation inside the for loop, but not getting the output, only some
Okay.
like a bit complex.
Complex. Can you tell me what's
Maybe power function or like.
Okay. Okay, power of I. So I'll just call it I will open the. Still, this is really fast. We can try.
Can you increase that to like whatever maximum limit is 10 to the power 9 or something?
Now it worked. If I, so these Goroutines are executing first. Got it?
Yeah, I still have a doubt. Like
So
we
this
put
is
a sleep.
yeah.
So we put the sleep after everything in the main, right? Then why did the stuff in main go sometimes after the go routines? That's my question actually. So we put sleep after over here, right?
Yeah, because we are waiting for other operations, right?
Yeah, that's true. That's true. But we are waiting because everything in main executed before, right?
Yeah.
Because it's very fast. But then at times we saw that, hello was coming after world sometimes before. Then why did that happen?
Because that is happening concurrently. So my machine has multiple cores. So each core will have multiple processors, right? So one processor will be running this thread, other processor will be running this thread, right? So to launch this thread, this will take some time. So that's why this was getting faster, fastly done. So this was printed first, and then
it wasn't at times,
example,
right?
Yeah.
It wasn't
What
at
do you
times.
want? Let's try that out. What changes do you want in this? You want to add time slip here? No, because this will launch after that anyways. So Goroutine should be launched after that only. We can wait, right?
Yeah. So, like we said, greeter world, right? Just can you just write it down, please? Yeah, like greeter world over here.
Do you mean here?
No, just new line after that, line 14.
One more function.
Like a function call. Yeah.
Okay, got it.
So since and then we had time dot sleep after this, right? Like, can you just remove the SPOW, like these lines? Yeah.
Okay.
And now you had added the sleep, right? After this line. So greeter world, because as we saw, 10 to the 8 was what we needed to have it execute after the threads. So anything shorter than that should always execute before, right?
So you mean what sleep should I add?
Yeah, can you just add the 2 seconds sleep that you had?
Okay.
Yeah. So now when we had run this, sometimes world executed after hello, right? Why did that happen?
Because yeah, right now, because launching and execution. So these are the things happening on different threads. You understood that part. So this is happening inside main thread. This is happening inside another thread, which is created by this main thread, launched by this main thread. Okay. So these are happening parallelly. So we only have 2 threads. So there is possibility that these 2 things are happening parallelly. So processor is not shared between these 2 tasks. This is possible, right? So sometimes it is possible that hello will come first after, like sometimes world will come first. This is concurrency. So you cannot guarantee the order, right?
So it's random.
This is mostly used in case where order doesn't matter, but your calculations matter. You want to make the calculations faster.
Okay.
Okay.
It's still a bit unclear, but I think we should go on. I'll ask this later.
Yeah. Let's discuss about this later. Okay. So this is how we define Goroutines. So Goroutines can be defined using anonymous functions as well. So like this, you need to call this function. Okay. So whenever you define this anonymous function. Okay. So this is how we create Goroutines. So when a new Goroutine is started, the Goroutine call returns. Call is returning immediately that it has launched Goroutine, but it needs to wait for main function to finish. Okay. So main is also one of the Goroutines. There is a way to print how many Goroutines currently exist. Okay. So let's say I have this function. So when this function got executed, so if I print fmt dot hello, so there is a package called runtime. Okay. So I just need to import it. this will print the number of Goroutine currently being executed. So when it was launched, there was only one main thread, and when it launched, this is the second. So that's why it printed 2. So yeah, if the Goroutine execution is done, then it will not print it. So you need to print this within Goroutine itself. So to count a number of Goroutines that have been launched. If I print this after this, let's see what's the output. Okay, so this has printed 3 because this was the one. This was still getting executed, so it says 3, and third one is main. Okay, so this is the one method you should know to check number of Goroutines that currently being launched. So these Goroutines can be launched, like multiple Goroutines you can launch within for loop. Okay, we already have for loop, so you can call this. So within this, you can call this greater as well. So this is how you can launch multiple Goroutines. Okay, and again, I need to add time slip for now. To know the output of these Goroutines which we launched. So this will launch 10 Goroutines and 10 will be executing this thing function. Okay. So these are the Goroutines which we use. So what is the other way to wait for Goroutines to exit? So this is basically 2 seconds we are waiting, but it is possible that Goroutine has taken less time than 2 seconds. Unnecessarily it has to wait for 2 seconds, right? So there is one way that is called as wait groups. So wait groups are provided by sync package in Go. Okay, so we'll import this sync. So we'll just remove this. We'll define wait group. So wait group can be defined using sync.wait group method. Type, structure type. Okay, so we can define this. So this is nothing but a counter. It maintains a counter. So to like this counter is nothing but a number of Goroutines that we are going to run. So let's say we have 10 Goroutines running. So we can add 10 here. So this will make counter as 10. And then we need to, like inside this Goroutine, we need to tell that this counter has, once this Goroutine function is executed, we need to tell that this Goroutine or this function execution is completed. So for that, we can just call done. Done will decrement the counter. Okay, so for this WG to be known by this function, we need to pass it. We just pass it. Wait group sync dot wait group. Okay, now this function knows about wait group. So we need to call done to decrement the counter, and there is a method to wait group dot wait, which will wait exact till the execution of these Goroutines are over. So it identifies execution of Goroutines are over with the help of this with wg.done, which decrements the counter. Till the counter gets to 0, it will execute, it will wait. Okay. So let's just try to run this. So let's do this. This is no more needed. Okay, this got executed. But it says all Goroutines are asleep, deadlock. Why? Because we are passing this WG as pass by value. So this will create another, like this will try to decrement this done. So we need to pass it by reference always. So when you pass, so it knows that we are talking about this counter. So it will exactly decrement this counter from main function. Okay, now it works. So this is the correct way to wait for main thread for execution of other threads, which are the Goroutines. Is this clear?
So can we add wait group dot done after line number 15?
Let's try that out. Okay. What do you think? Will it work? No, this will not work. I have removed it, right? Yes, removed it. So this will again say deadlock, because so we are adding 10 counter, but we are decrementing only once.
No, inside the for loop.
Inside the for loop, you mean?
Yeah.
Okay. But this will be executed before Goroutine executes, right? Okay, let's see. So it will not wait. Nothing will happen. So this is similar to not adding wait groups without time sleep as well.
Okay,
Because
okay.
this just added and decremented. So there is no way to know like whether this Goroutine has finished its execution or not. So it just checks counter. So this we are running sequentially. So when we add it, we are just decrementing it sequentially. So till the code control reaches here, its counter is 0. So it will automatically execute next line, which is nothing. So it will exit. So you need to do this wait group dot done once your Goroutine is completed. Okay. So to remind this, so you must have heard or used differ, right? So that we don't forget. So this is one way to remember. We do not mark it as done. Otherwise, your program will end up into deadlock. Deadlock is nothing but something we are waiting to happen, but this is not happening. Okay. So let's say if I don't do this, wait group dot done. Okay. I'm still waiting. So there is something I'm waiting to happen, like at some time this should be end, but this is not happening. So this is end up into deadlock. Okay, so we must remember that whenever we use this wait group, we should add wait group dot done at the end of the Goroutine. Okay, or you can add it at the initial using this differ. Okay, is this clear? Is this clear? Let's just take a quick like output guessing game. Okay, let's say if I add just 1 to it, okay, but I am launching 10 Goroutines. What will be the output? Error. Okay, what else? 5 hellos. Let's just see. 5 hellos. Why this has happened? Can anyone answer? Let's just run it once again. Now this has run more times. Because we are launching this Goroutines multiple times, right? These are going to execute parallelly or concurrently, right? So we just added 1 till the first getting executed, other 7 or 6 are getting also executed. So that's why it's printing 7. So it will not wait for all the Goroutines to finish, because it just know 1 counter. So whenever that one done is done, it will exit.
Sorry, but can you please explain it again once more?
So we have added 1 to our counter, right? And we are launching 10 Goroutines. Okay. So these are going to execute concurrently or parallelly. So sequence is not fixed, right? So
Yes.
Can we pass the value of I to the greater function and print it beside hello?
okay, so you mean we should pass. So after for loop, you want me to print this I.
Can you
Right.
remove hello? That would be better to visualize. Like 5 hellos are not that easy to visualize.
So how does it matter to pass? How do you?
You can print only the counter like in the loop.
Yeah. So it's like 1, 2, 3, 4, 5. Then which one is printing earlier? Sometimes you can get some insights out of it.
Yeah, so that is what I was doing. So this will print the counter, like which at which counters Goroutine is getting executed.
You can print along with hello only, right? In the string, you can add one more argument. in that
str
hello.
comma counter.
No, but execution I'm talking about. So this will
Yeah,
be
execution
launched.
only. Yeah, so actually the hello with executed with which counter we can know from the loop, the print statement on line number 29.
Okay, let's just do it. Okay. Okay, this executed for first. So when first loop was over, it just executed WaitGroup.done, and it came to know that 0 has happened, so it just exited. So let's run it one more time. So it executed, like these are the things. There were Goroutines launched, right? And then it started execution. It took 9th counter Goroutine first. It was getting executed. And also one was done 5 times. Then it first counter Goroutine marked done as like first it marked it as done. It was the counter 1 was the first who was marking this as done. So as soon as this was done, this got executed.
Can you rerun once?
Yeah, this will change. So now 9th counter was getting executed, and it happened 5 times, and then it marked it as done. So some counter will execute 5 times, and some counter Goroutine will execute few times. So this will happen, yes.
Can you please add time dot, some waiting time before wait group dot wait, yeah. After, before line number 17.
Okay, yeah, this will execute everything because this is really fast.
No, but that should give error, no?
Why?
Because we have added only in wait group we had only added 1, not 10.
Okay, let's just check. That's your point is also valid, yes, because the counter has gone to negative value. Negative wait group counter. This will give an error, right?
Got it.
Okay, so this should be always reach to 0 value. If it is going to negative value or it is not decrementing, in that case it will give an error. Is this problem clear to you guys? This one?
The error is coming because the wait group counter goes to negative value, right?
Yeah, like when this line got executed, it got negative counter.
Okay.
That's why it throws this error. It is expecting to be value to be 0. If it's more than 0, then it will wait. If it's 0, then it will execute next line. That means it will return. And if it's negative, it will give an error. Is that clear?
Can you repeat how did it become negative?
So we have added 1 counter to it, okay, to wait group. And now we have launched 10 Goroutines and we are waiting here. So in this waiting time, all these Goroutines executed and everyone marked this wait group as done, which means it has decremented the counter by 10, right? 1 minus 10, that is minus 9. Counter has become minus 9. After this slip, it executes this line. Now the counter is minus 9. So this function gives an error if the counter reaches minus 9. So for this function, there are 3 cases. One is if it has value more than 0, then it will wait. If it has value 0, then it will return, that is go to next line. And if it has negative value, it will again give an error that negative wait ground. That means something is wrong.
I think the error occurred when the second thread made it negative in line 30, I think. So when hello 1 made it negative, I think that's when the error happened directly at the moment. Could you just go to line 30? Is it and check the logs just a moment?
Okay, so that means time dot second is blocking anyway. It will not, if you want, I can print it here.
Yeah, it might be before the sleep timer actually. It could be. I mean, it's possible that it happens afterwards as well.
Yeah.
Yeah, could you just do that print statement you were just doing right now, like after 19?
So,
Yeah, so I think like when the second go routine ended and when it
I think
had
done
marked it
itself is
immediately at that moment it did it. Yeah.
done itself is giving that error. It is not waiting for wait. Like wait is not giving that error. Done is giving that error. Okay, that might be my mistake. Okay. Good observation, but
So by using go keyword, are we using concurrency or are we also achieving the parallelism too?
so Go supports concurrency. So sometimes like if there are like two processors available and I just have two routines, then it will happen in parallel. Depends on processor, like how processor is available for the action. Okay, so is this clear? Go routines. No, wait groups, sorry. So in the wait groups, we saw this is to wait for multiple go routines to finish. The wait group is provided by sync package. This is used for the program to finish all the go routines launched from the main function. This is clear. It uses counter. Wait blocks execution of program until the wait group counter is 0. Okay. So these are the few things we already saw, that done must be called as many times as add. Otherwise counter value will be like inappropriate, whether it will go to deadlock or it will give negative counter, right? So if call to done are less than calls to add, then it will be deadlock, right? If we do not decrement counter as many times as we added, so this will also cause deadlock because wait will remain in wait state. So that's why it will never be completed. So that's why it is deadlock. Okay. Is this clear? These 2 points? Okay. If calls to done are more than call to add, then it will panic. Let's see that example. Why this will happen? Can anyone explain? You must have understood this concept, right? If call to done are more than call to add, then it will give panic.
Negative counter.
Correct. Calling wait without calling add will return immediately. So if we don't call add, we just call wait, so it will return immediately. Why is that?
The counter is at 0 already. So.
Correct. And sync wait group must be always passed by reference, right? Otherwise it will cause deadlock. Sorry, it will cause panic because of negative counter. Because in case of pass by value, the counter's value will be 0, and whenever it call wait dot done, that will go into negative. That's why it will cause panic. Is this clear?
Sorry, it should be deadlock, no? For point number 5.
Why?
Because we have, let's say we have already specified the number of go routines in the add, and we are passing it by, let's say, passing by value. Then let's say we are in that function, we are, let's say, saying wait group dot done, but the changes will not be reflected back in main function. So
Yeah, but wait group done itself gives an error, right? Negative in negative case. Let's say, let's call this. Yeah, both the things are possible. Let's see what it gives. Your point is also valid. So the question was, if we pass by value and we call it as done, just remove this.
can you please make, I mean, I less than 1 at line number 15? May panic.
I less than 1.
Yeah, because we have added only one routine at line number 13.
So this will give deadlock. So let's run one more
Yeah.
time. Okay, because wait is getting executed first. So wait is in the wait state, but it should have even panic because this counter is. Let me try once again.
So shouldn't it be a deadlock only? I mean, every single function will have the counter as 1 sent to it. Or let's say if we had WG at 10. And
sorry, you said 10?
yeah, let's say we have 10 and we have 10 routines.
Mhm.
So for every one of them, the counter will only go to 9 at max. So it'll never go to 0.
Correct. So in this case,
So
exactly, if I
think
do
Yeah, it will always give deadlock.
yeah, it should always give a deadlock.
Yeah, correct.
okay, that's a correction then. So this will be a deadlock. This is not a, in case of pass by value, it will give deadlock. Okay, so these are the few points you should remember about wait groups. Is that clear? Can somebody say yes or no? Yes, okay. Okay, so let's go to channels then. So what are the channels? Okay, so before going to channels, do you want to have some break? It's already 10. Okay. Okay, let's take break for 10 minutes. Is that fine? We can come back at 10:15. Okay. Okay, you guys can go for the Okay, guys, everyone is back. Is everyone back? Yes, okay. Okay, great. Let's get started then for the next session. Okay, let's just have a quick recap what we saw till now. So we started with like how Go was invented, what was the basic principle behind channels. Okay, what was that? What was the principle? Can anyone remember? Do not communicate by sharing memory. Instead, share memory by communicating. Share memory by communicating is what Go channel suggests. Communicate while sharing. So that was communicating sequential processes. That was the main paper which was referred by those people. So which was communicating sequential processes. Do not communicate by sharing memory. Instead, share memory by communicating. Okay. So let's see how this works in Golang. Okay. So when we started with Goroutines, our basic program was this. Am I audible clearly? Yes. Okay. Thanks. So we started when we started Goroutine. So we had this program greeter, which was printing this hello 5 times, and we had added this Go in front of it. Okay, for launching the Goroutine. There was one more Go, but I just removed it for now. So this function right now printing this str which we are passing here, but let's say if we want to let main thread print it, so we want to communicate this Goroutine with this main thread. How should we do it? So in that case, channels comes into picture. Okay, so let's just create channel. To create channel, you just need to use make channel keyword, channel of type. What type of channel you want to create? So here we want to print hello message. So we want to write this. We want this message, this function to return this same string to main. So that's why we'll create this channel as string. Okay, this is the simple make syntax you must have seen. So there are you can create maps, slices using this make, right? Right. So similarly, you can create initialize channels using this make syntax. Okay. So you just need to write main inside that channel of type string. If you want to create channel of type integer where you want to write integer value on it, then you will create channel of type integer. And if you want to create array of integer or slice of integer, then you can define it like this. Okay. Is this clear how to initialize channel? Right now we want string. Channel as string. Okay. So now what we'll do is we will pass this channel to this Goroutine because it needs to write on this channel. Okay. So this is the shared channel between main thread and this greeter thread. So that's why we need to define it inside the common place where both these threads can access. Okay. So we will create this and we will pass this to this channel of type string. Okay. And this is how we passed it, but how to use it? To use it, you just need to write. So there is a syntax, channel, this arrow, and then you just need to write the message. So this arrow indicates data flow direction. Okay. So this data will go onto this channel. This is what it means. Okay. So this is how this Goroutine has written some message of type string on this channel. Okay. So now how main thread will come to know what message has been written, or how will it read it? So for that, we want to get some message in some variable. Okay, so we'll define this variable. And to read message from channel, so you just need to write this arrow again. So here data direction from channel to this message variable. Is this clear? These three things. One is how to define a channel, initialize a channel, and then how to write on a channel. Okay, data should be on right side in case of writing onto channel. Okay, so this always you remember this flow. This direction indicates data flow direction. So this is the data. Data will go from this to this channel. And here, so data from channel will go from this to this message variable. Is this clear? What are the different data types allowed from channel? So you can define any type of channel. So what all the data types, whatever supported in Golang, you can define it here. Yes.
Line number 15, we should be using pointer to the channel, no?
No, not required here.
Why? Like how, like why are
This
changes?
is the shared variable, right? Shared variable we are asking. So yeah, this works.
Okay.
Just try out. Let me just try out. I'll just print it out. So this running or not. Okay, this worked. Okay, so so this will work. So you don't, when you create this make, so this will pass it as reference only. So you do not need to specify as star. There is nothing like star in channel.
So why are we having 3 hellos in the standard output?
So basically, so we are creating this channel. So this, I was also expecting this as once only because we are just
Some like so that we can identify like in line number 12 beside message something else, another is a message plus a different
oh
string.
no, plus is not happening for sure. Let's just run it. Acha, okay. No, this is glitter. Hello. Okay, we are printing it here. That's why it's getting printed. Okay. So this will read only one message because like once this is happening in sequential manner, right? So this will be written once first time it was written. So this will listen to it and this will print it. So this is also one way to block it. The main thread channel. So first way we saw was time.sleep. Another way is wait group, and third way is this. So this will basically, as in the example of piggy bank, we saw that one person is holding piggy bank till other gets it. So it is blocked, right? So this is how it is. So this channel is holding till the value is being right. Someone is there to get it. So once someone writes something on it, someone is ready to get the data, so it will be released. Till then, it will not execute. So let's say if I add some time sleep here, okay. So till this write happens, it will block itself. this line. So this is happening fast. So this online editor is really fast. This doesn't take, I think, exact this time. So if I run this locally, you will notice that this will exactly take time, not second, 2 seconds. So this is on this online playground, it happens really fast. If you want, I can run this locally. Okay. So this critter is getting executed. So after 2 seconds, if I increase this time to 10 seconds, it will be noticeable.
We are showing the online ID only.
Sorry. Acha, okay, sorry. I think my screen is not completely shared. Let me reshare it. Is this visible now?
Yes.
Okay, so in this channel.go, I did the same program. I just incremented this counter. So when this greeter will start, so we are blocking this main thread using this channel. So till something is written on the channel, it will wait. So I have increased this time to 10 seconds. After 10 seconds, it will write something on this channel. And once this is written, so this will get it and this will execute next line. Okay, so this is what I'm trying to show. So it takes 10 seconds and then it prints test hello. Okay, so in the online editor, it was not taking exactly 2 seconds. It was really fast. So I wanted to show that loop.
So as soon as message is written into the channel, then the control will reach main Goroutine. Is it?
Correct. Yes.
Okay.
So when this was happening, so this launches, main thread was executing, this launches this thread and it goes to this line, but there was nothing which was written, so it will wait, similar to waitgroup.wait.
The control will break at line number 20. So let's say we have written few statements after line number 20. So those statements won't be executed.
Right.
Okay, got it.
Okay, so so this is how channel communicates. So basically, if you see, so we already saw this part. So this is nothing but a pipe way. Channel is nothing but a pipe. Let's say this is the main thread we have, and this is our Goroutine. Okay. So till the Goroutine writes something, main thread will be blocked. And this communication happens like over a channel, which is nothing but like a pipe. Okay. So whenever something is written, it will read it and go ahead. And if let's say, let's play around with it. Okay. If I don't listen to it, what will happen? Let's do vice versa. We will just wait, but we will not write. So this will give deadlock again because it is waiting for something to happen, but it's not happening. So that's why it will give deadlock. So you need to have receiver as well as sender. So this Goroutine is sending message and this is listening. If we don't have one of them, this will not work. So this is how channel works. So you need to have receiver as well as sender. Okay.
So like if you have more than one Goroutine at a time, does every routine have to send a message? Otherwise it's locked, or just any one will work?
So it depends on like only one would be sufficient, not all. So Let's say
Okay.
if you have two Goroutines, if anyone sends, then that's fine.
Yeah, we're not sending anything right now. Okay. Okay.
But here you see, we are like looping over this. We are sending multiple messages, but we are getting only one. So how to read all the messages? So is there any loop we can use here? Anyone? So let's say if I want to read multiple values, so I can use this for loop. What does this indicate? This for loop?
Infinite loop.
Correct. So it will like this, it doesn't know how many messages the sender is going to send. So this is a receiver. Main thread is a receiver right now. Okay, so it doesn't know okay, how many messages this this function is going to send, right? It is unaware of this, correct? So this we need to run it inside a for loop. Okay, let's try to run this. What happens? What will happen? Deadlock again. Why?
For loop.
Correct.
Stop.
We are
It's still
on-
waiting.
Yeah, it's still waiting.
We're waiting.
Got all the responses, but it's still waiting. There is no one to send anymore. Right? This completes its execution, it stops sending, but this is still waiting. So that's why it caused deadlock. Okay. So to avoid this, what can be done? So there is one method called as closed channel. Okay. So once sender completes sending, so he can say it as closed channel. Okay. And in the other thread can have like can come to know that whether the channel has been closed or not. If not open, then we can just return. Okay. Otherwise, it will print. Let's just run it. Okay. So this closed channel is important. So whenever you use this channel, you need to close this after your use from sender side. You cannot, if you close this on, where can we close it? Let's say if I close it here, then what will happen? It will again go into some kind of message, which is panic. It will, so we are trying to send. So receiver doesn't know when sender is going to stop sending. So if it tries to close it, then we'll get this error because we are sending on closed channel. Okay, so we always need to make sure that we are closing this channel. Okay, on sender side once it is done. Okay, is this clear? So it returns two values. One is actual value sent by the sender and other is whether the channel is open or not. If channel is not open, then we are going to return it. Is this clear?
Yeah, I mean, this part is clear, but like I didn't get how channel is actually handling the race condition problems.
So channel, how it is handling, you mean what kind of race you see here?
I mean, it can be anything, no? Let's say, suppose two or more Goroutines are accessing same memory, then how we can make use of channel to make sure that we don't face race condition.
No, it is like it already handles it internally. So it, we do not need to care about it. Channel will allow only one Goroutine to write on it. So it does everything in atomic operation.
Okay, so let's say can you please open that function?
Yeah, this one.
So let's say until, I mean, till we don't return or till we don't write any messages in channel, no other Goroutine can access this function or can start its execution. Is what you mean to say?
Sorry, I didn't get. Can you please repeat?
Okay, so what I'm saying is, till like any Goroutine doesn't put anything on this channel. So can we say that the channel doesn't allow any more Goroutine to execute? Until or unless
No, no.
main doesn't receive anything from, let's say, any goroutine, it doesn't allow any goroutine to start
No,
its
no. So
execution.
those goroutines will be happening on different threads, right?
Yeah, correct.
So those will not be blocked. So those will still be executing. Let's say this is the example. Okay. So let's run it locally. Maybe that will be sure. Okay. In this program, let's add one more. Okay. Let's add one more this. And let's just create different function instead of this greater. We'll just write. So this main greater function is waiting for 10 seconds, right? So this another function which I'm writing, another goroutine. Okay. This will not wait. So I'll just do something like print something here. Okay. Okay, so you mean to say when this is being waited, will this work or not? Right?
Yes.
Yeah, let's see. So this worked. This already executed because it doesn't have to wait. So it was happening concurrently. So it got the processor, it executed. So another thread was executing another goroutine which was greater. So it completes its execution and program gets ended.
Got it.
Okay. Okay, hope this is clear to you all. Any other questions?
Yeah. Can you go to the local code?
Sorry?
Yeah, can you go to the local editor? Not the local editor you were doing.
Locally,
Not the online.
okay. Hmm.
Yeah. Yeah.
And then?
In this function, can we use the same channel inside the anonymous function?
Yeah, we can do it. So if you want to take this anonymous function, can use these variables directly. So we do not need to pass it like we passed it here. So let's just write something before the second function, right? We are writing something here. Okay. Let's just say word. Okay. Got it. So this just executed this one. This didn't wait for this to finish. Okay. So it just like it got channel got one response from anonymous function. So this, so we are just listening one time here. If we loop over it, then we'll get this as well as all these values.
Okay.
We have just heard only once for this channel. So it just printed one and exited. If we would have for loop, then it would wait for all the messages coming from all other goroutines. Is this clear?
Yes, clear.
Okay. Okay, we just saw how to close a channel. So let's just quickly recap it. So to initialize a channel, we just need to use of this make channel of type integer, string, whatever you want, you can do it. To write on the channel, you just need to pass like this. So this arrow indicates data flow direction. Okay. So this value will be written on this channel. This is what this means. So if you want to read from channel, then you just need to write this arrow here. So you are reading from channel to this variable. Okay. So you always do not need to like specify this variable. You can, this will return one value which you can directly read as well. For example, if I don't, right now I have used it here for loop, but let's just say I just want to read one value. I do not want to check open or close. Okay. So I can just print fmt dot. I can just print this as well. This will also work. This will also block the thread. You don't, always do not need to like specify the variable. Okay. Okay. So this is how we define the channel, write on the channel, read from the channel. And once sender is complete receiving on channel, we can just close it. Okay. Okay. So similarly, there is one more way. Like, so instead of doing this message open, there is one more way to listen to the messages. We can just range our messages. So you must be heard of range, right? For. So let's say this returns some value. We will range over this channel. So this will read all the messages. Instead of for loop, you can just use. You do not need to check this condition now. So you can just for loop. So this for loop will run till the channel is closed. Okay. So this is one more way you can read messages from the channel. Okay. I have just closed after one. So it just 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, the second was executed 4 times. Till then, this got executed. So both the Goroutines were executing parallelly. First completed 5 times and then it executed close. So at that time, second Goroutine had executed 4. So that's why it printed 9. So once channel is closed, it will stop listening to it. Okay, is this clear? Range syntax. So instead of for in the for loop checking for whether the channel is open or not, you can use this range. You can range over a channel. Is this clear?
Then how would we like get all the outputs? Like we need all 10. So how would we do that then?
So you mean messages from both the.
Yeah, like we got 9, right? We didn't get all 10.
Yeah.
So how should we do that?
Then you
Can we pass different string to the second routine?
sorry.
A different string, different string to the second routine. Can we pass like not hello?
World.
Different one.
Okay. So this will execute in any order. So whatever message it gets first, it will print first. So if we want to do that, which someone was asking, like, how can we close this channel after all the Goroutines are done? So for that, what can be done? Can anyone tell what can be done? If we need to close this channel once these Goroutines are completely closed, like done. How can we do it?
Yeah, something like a wait group, like Yash's mentioned maybe.
Yeah. We can
So
do
like after the final wait, we can close the channel.
Correct.
Something like that.
So yeah, that is also one way. Okay, is that fine?
So I think that close will only be in the main one. And I think after
Yes.
the close will not
Oh,
be in
right.
the
Sender.
go
Yes.
then. Yeah. Like
Yes.
I'll have to do all the wait groups. Yeah.
And We need to pass this wait group as well. So wait group should be passed by reference. Wait group dot done. And what else I'm missing?
Add.
Wait group dot add. How many should I add?
2.
2.
For 2 routines, we need to add 2. Okay, and yeah, so this will be done. And then we need to wait. Yeah, but this will create some problem. What do we need to create? Let's just try out first, then see what problem. Okay.
Yeah, nothing will happen.
Why? What happened here? Because we are closing this channel and then we are again listening to this where no one is sending.
Can we close the channel in line 24?
On line number?
24.
Can someone tell, will this work? Again deadlock, because this, how does it know when to close it? Like this works till the channel is closed, right? So this will again run into infinite loop. So it will again give deadlock. This will not work in this case. Maybe keep a counter for the number of goroutines before closing the channel. Maybe keep a counter before closing the channel. Okay, you mean here itself? If counter is reached to 2, then close it. This is what you're trying to say? Yes, okay. So that is one way you can do it. I never come across such situation somehow, but yeah, that is
So,
one way you can do it. Right?
Like, can we have a for loop?
Mhm.
I mean, like a while loop set up with a for, obviously. So, and then in that for condition, just check if, you know,
Channel is
the counter is 0.
okay.
Oh, yeah, actually, the channel is, yeah.
But where will you close the channel? That is the question we are trying to solve. So earlier we were doing it here. Okay. But what was happening? It was closing once one of the coroutine is finished, right?
Yeah.
There is one more way you can do it. You can create one more channel. This channel pass one channel to this, another channel to this, and you loop all both. Like first coroutine will write on first channel, second coroutine will write second channel. That is one way. And another way, which like Shubham was suggesting, we can keep a counter and pass this to reader function. If counter reaches, then we can do it. We can call a close. So in that way, let's just try that out.
The counter can be a normal variable, or should it be something like a channel?
No, normal.
Okay.
There are many ways actually. We can see this further slides, like where we'll learn select syntax. Okay, this is a counter. Let's pass this counter to this as well. Just remove this wait group for now. This is not required, right? If counter is equal to what should be the value of counter? 1. Then only close it. This is the one way actually. Too many arguments in call to greeters, str, channel, and counter. How many messages it printed? I'll just remove this.
Star counter.
One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's just pass by reference. So what I need to do here?
Star counter. We have to access it using star.
Is this correct? This will not work. I think.
Another star at line 28.
928, 928.
Where 9?
Line 28. Line 28.
Star
Got it.
counter.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it worked. Okay. So this is one way, but there are many ways to do it. Let's see it like further. Okay, this is clear. Range. What all things we saw for channel? How to create a channel, how to write on the channel, how to read, like how to read multiple messages from the channel, right? Till it is closed, how to close a channel, when to close, who will close it, right? Okay, till this clear, channel is clear till this. Can anyone reply? Okay.
Just a small doubt. Like, shouldn't it be counter equals 2? How is it still working with 1? I'm really
Because-
confused with that.
What is the default value of counter?
It will be 0, right?
0. Okay. So initially when it comes, it will be counter plus plus. So counter plus 1, right? You are right, I think. Yeah, this is correct. Because we are incrementing this. So initially it will be 1. In the first case itself, it will close it. So another will not happen. But I think in that case, the second already executed and it has counter 0, not sure, like something race condition was there. So in this case, there will be a race. We'll see this further, okay? This is not the correct solution actually. This will cause a race.
Okay.
Okay. We'll see this and how can we do it. Okay. So yeah, let's move ahead. Okay, we are done with this closing of channel. And then we had range. We saw how to use range, when to use. So whenever we want to read all the messages from channel till it is closed, we should use range. Okay. So we saw values. So value is not written onto channel until someone tries to read it. Similarly, value is not read from the channel until someone tries to write it. So let's take one example. Okay. This is,
Hi Ashwin,
yeah.
could you please repeat the range once again? Like I got disconnected in between.
Okay. So you are there for the like channel will return 2 values whenever we read. From
Yeah, till the close of channel. The
Right, close
demo
channel.
for close.
Okay. So always sender needs to close it. Okay. So let's just change this. So there is one way to, like, if we try to read multiple messages from the channel, so there was one way to loop it over infinitely. Okay. So I'll just print. Okay. Sorry. Earlier we were not having this close clause. Okay. If we don't have it, then what will happen? This will go into deadlock because this sender has stopped sending, because once it has completed its 5 messages, it will stop sending, right? But this receiver is still listening to this channel. So that's why we got deadlock. Okay. So to avoid this, we need to use close channel. We need to close it. So we have, till we close the channel, it will work. But let's say we, but this will not give all the values. Let's remove this. It's not so confusing. Greater channel, greater string channel is not a timeout. Okay, this is problem, editor's problem. Let me try it. Okay, this is still running. So what we need to do is we need to, like, there are two ways to listen to the closing of channel. One is this: whenever we read from the channel, there are two values it returns. One is message, other is whether the channel is open or not. So if the channel is not open, so we can just return it. This will not be by default. When we create, this is open. So when we explicitly call close, then it will be closed. So in that case, we will get value as false. Okay. And this condition will become true. And in this case, we'll return. Okay. So this is one way to listen to the values from channel. Multiple values from the channel. Okay. Okay. So this is somewhat lengthy, right? So there is one more way Go provides. You can range over the channel. Just change this channel. Message. So this range will work till the channel is closed. So this check is not required whether the channel is open. So this is a simple syntax which you can use for channel. Okay. Is this clear? This is what range is.
Yeah, got it. Thanks.
But you need to close that channel. Okay. If you don't close it, then it will end up into deadlock again.
Yeah.
Okay. So this will go into deadlock. So this is what range is. Okay, let's try to play around with it. Okay. So we saw whenever whenever we try to read the message, channel gets blocked. But what happens if we try to write on the channel? So what will be the output of this program? Can someone tell? Okay. So I'll just print it. Okay, I'll just erase this. This is not required. So what will be the output of this program? Can anyone tell me what will happen? Anyone? Anyone knows what will happen here? If not, let's try out. No, right? You guys don't know what will happen.
I mean, the channel is of type string and we are
Oh,
sending
sorry,
an
that is
integer.
wrong. Correct. That's good observation. We just write string. Okay, now
Like like it's trying to send it, but there's no channel receiving it. So
correct.
it's like not in parallel. It's like afterwards, not at the same time.
Correct. Correct. This will again go into deadlock because it needs to have receiver as well. So this is sender. It needs to have. So that's why like this will block on this. It didn't find any like receiver before it started. So this will be blocked and next line will not be executed. So there is one way we can like avoid it. So there is we can specify this capacity of channel. Like if we define this capacity, we add this capacity, then it will not block. This works because this basically create a buffered channel. So in this buffered channel, it will not block till the channel is full. So after this, if I try to write something, this will again block. I have capacity of 1. Okay. So if I try to write, so this will again go into deadlock. If I increase this capacity, then it will again work. So this buffered channel will start blocking once it is full, after it is full. Okay. So this is one type of channel you can use. Okay. Until the channel is full, it doesn't go to blocking state. Otherwise, the normal channel which we saw without capacity, which blocks. This is called as unbuffered channel. So if we try to write on it, so this will block. Okay. So these are the two types of channel we have. One is buffered, other is unbuffered. In case of buffered, we need to specify the capacity. Okay. So this is about buffered channel. So let's say now we have multiple channels. Okay. How to work with that? So as I think previous UI was better than this one. Okay. So let's create one more channel. How we can work with multiple channels. Let's see. Let's create one more channel, channel 1. Well, this is called a channel 1. This is channel 2. Make channel of type, let's say integer. This time we'll call 2 Goroutines. Let's say this calculates sum. Text value is integer 2, 3. ch2 ch1. Okay. Let's write a sum function. Okay. So you must have observed that this go routine doesn't return anything. Okay. You cannot have this return value for this. This happens in the background, so we cannot read it. Okay, so here that's why we are not returning here. So instead, whenever we use go routines, we use channels to communicate. So what values it is written for that. So let's say this channel, let's call it as channel itself. So on this channel, we will just write X plus Y. Okay. And here we want to listen on both the channels. Let's just create it as buffered channel so that it doesn't get blocked, and we'll just print both the values. Or we could have used that as well. Not a problem. Okay. We do not need to close this channel actually. So I run it again. So this is always printing hello first and 5 later. Okay, so this means okay, this is we are reading from the channel, so this will block, right? So that's why it is printing hello first, then 5. Okay, but it is possible that we are getting some first and then we are getting hello. So how to detect that? So for that we have one syntax like select. Select is nothing but a switch case in your C programming. So in this case, select. So we can listen to channel 1 as well as this channel 2. I'll just keep this map in some variable. Now what will happen? So this will wait for any of this value. So if it gets sum first, then it will print this. If it gets hello first, then it will print this. So let's try to run this. Yeah, I'll remove this. Okay, this is happening only once because we haven't written for loop. So this is like this will be executed only once. Whenever we get one value, this will just execute. Sorry, return. So if you want to type, listen to multiple values. So
Why link switch? Like, what is the purpose?
Select. So purpose of select is basically for listening to the channels. So multiple channels. So
Like we can listen individually also, right?
yeah, but that is blocking, right? So you don't know like on which channel you are going to get the data first, right? It is possible that hello will get first. So till
But
then
we-
we are blocked.
But we will get data in both the channels. So like if we write channel 1 will receive from say the greater Goroutine, and channel 2 will receive from the sum routine. So both will routine and both will return, and then we can print both the values.
Yeah, that's right. But let's say if I have to perform some operations on it, let's say that will get delayed, right? So let's say I got the sum and I again want to make it square once I get the data right here. So that will get delayed, right? If I listen to the channel 1 first, you don't know which value you're going to get first, right? So if you write channel 1 first in your print,
That destroys the purpose of concurrency. Like if we are waiting for the data in order, if we are wanting, then the purpose of concurrency is destroyed. concurrency.
This will be destroyed. So if you specify this, so this will destroy your like concurrency thing.
No, here concurrency is maintained, right?
Maintain, but still, like, you cannot perform this operation. Let's say if I want to perform something on this data, let's say I want to launch one more Goroutine once I get the data from first Goroutine.
Okay.
So in that case, you don't know, like, you are still, you're waiting for this first, right? Channel 1, this is blocking, right? Reading of this channel. Till you get it, till someone writes it, this will be blocked.
You can write the second line above the first line.
But how do you know which one will come first? Let's say if you do this, but my operation was for this one. So for both of them, we have something handled. So let's say if I get hello one, I launch some one Goroutine. If I get some, I have some other operations to perform. But if I wait on one of them, I don't know which one will come first, right? This is Goroutine. So this will happen in any sequence, right? Am I right or not?
Okay.
So for that, you will need this select. So where you do not need to know, okay, which one will come first. So you can just use select, whichever will come first, I'll use that. That is what it says. Okay. So you can listen to the multiple channels using this select. Okay. So once you get this data, you can do any operation if you want. If you see, so this will work only once, because this is like switch case. If my one case matches, it will execute and exit. So this will not go into like check for one more case. So to make it work, so we can just add for loop. Okay. So what will happen now? What will happen now? So this will
it again go into deadlock?
Correct. So this channel was getting multiple data, so that's why it printed multiple times. This was getting only once. So what can we do here? So yeah, close will require. You can use close here as well. And one more way would be, you cannot range inside this because this is case. So what can you do? What can you do? Can anyone suggest? Like, if I want to get out of this loop? Can anyone think?
So like we have the other, second variable from a channel, right? So if both of them are closed, we can have a if condition at the end of this select state. But like if ch1 is closed and ch2 is closed, then we just break out of the for loop. Something like that.
So you mean here, I need to write this.
Yeah, so like we have a, like outside this for loop, we just have two variables, each for check one, like bools, two bool values, which are currently set at true. And every time, and then we have this open variable, which we'll check. If it's closed, we assign the bool ch1 to be false. And if we get open for the second channel as false, then we'll
open channel to open. Okay. So we can have this.
Yeah, and both are true at the beginning.
Both are Boolean type. So we can just,
yeah.
Sorry. Channel 1. Open. And here also channel 2 open. Okay. And both are closed. Then only we want, right?
Yeah.
Channel, sorry. Then we can return from here. Right? You can just write data here. So let's try this also. What happened? Why is open is
I
correct?
think this is a local variable. Like
Mhm.
19 and 21 are ch1 opens which are being created locally. And the outside one is not being used, like line 15 one, the one on line 15. Those are not being used.
So we can do this. So data is of different types. So we need to create two variables, then type string.
We can use blank variable as well. Yeah.
Which variable? Sorry.
Blank variable.
What is that blank variable? You mean colon equal to? Do you mean that colon equal to? What is blank variable? I'm hearing this for the first time.
Yeah, I have put this in chat box.
Acha, you mean that? But I want to print this data, right? Which I got. Blank variable we use in the case where we do not want to use it. Unused kind of value, right?
Yeah.
Data str. Okay, not being used. Undefined data. Where did I use actually that word only?
You haven't closed in the actual functions, I think. Close the channels. You have to close the channels, right?
Is this conditional? Because close is not required here because close.
You have to close the channels, right? So that it can break out.
No, but here we are not using like we are not. Oh, got it. Your point is valid, correct? Because we are using that open thing, which needs to have this close channel, and here also we need to close. You're right. Correct? Is this correct now?
Yeah.
In line 23, data from channel, it should be channel 2, right?
Sorry, your voice was.
In line 23, the print ln statement,
Mhm.
data from channel 2.
Yeah,
Yeah,
that is
it will be
correct.
confusing.
But it is reading only one value. Okay, you guys can try out. So there are ways. So in the similar concepts you can use and like solve this problem where you can print all the values. Okay, we are running out of time actually. So you can try this out. Yeah. Okay, if we want to print all the values from this channel one, it is just printing only one, right?
I think what's happening is ch2 0 open is already false default value. I think you should set both to true before. Could you just do that? I think when we get over here, I think when you receive from one channel, the second value is false. So if the first channel closes before receiving value from the second one, I think it's causing an error. In line 15, could you just default them to true? I mean, not default, assign them true at the beginning. Yeah, both of these.
No, but by default channels are closed only, like open. So
That is the channel type, not the channel value. Bool is the channel value which it will be holding. Channel will be open by default, right?
yes. Okay. So
Yeah, so you should set it as true, right? It's false at the beginning, so that's why.
I think you're right.
and remove the var thing. Okay, yeah.
This works. Correct. Good observation. Okay, so this printed all the things. Okay, so this is sorted. So select when do you select when you want to, like, you have 2 channels or multiple channels, you want to listen to all of them, then you can use this. Okay. So there is one more default case here you can also define. So this is for, like, let's say in case there is nothing on this channel, in that time, if you want to do something, it will be get some data on these channels. If you want to print something or do something, in that case, you can use this default statement as well. So this is nothing but our switch case. So this printed only once. So this is running inside for loop. So this might happen multiple times. Yeah, right now this is happening faster. So this is getting only once printed, but like, so this is how you can use select. Got it? Clear? So from the channel, we saw ranging over channel, closing channel, buffered channel, unbuffered channel. Okay, and select clause, how can we use it? So next, let's, okay, this was done. Select case we saw. Okay, next is sync and mutex. Okay, as like earlier example, we were trying to update a counter. Do you guys remember? So let's say let's try this one example. Okay. So here is one example we have, like, which is what it is doing is it is incrementing this counter. There is a shared variable we have X. Okay. We are trying to update it. Let's say we have this situation. We want to keep this global counter and we want to update it from like every go routine. Okay. This go routine is trying to update it. So what should be the output of this ideally? So in this problem, someone was mentioning that why CH1 got multiple times. CH some got. Okay, we'll see this later. Let's we'll remember this. We'll come back to this. Let's try to answer this first. Okay. 1000. Yeah, ideally this should be 1000. But let's see what is happening. So this is giving 860. The next one it is giving 994. Why this is happening? Because there is a race condition. So these are the multiple go routines. Multiple processes are trying to access this variable. They are trying to update it. So there is a race happening. So like sometimes when it was reading, it was like some 900 and suddenly someone updated it 901, but it already read it as 90. So that's why it just incremented to 901. But some other go routine has already read it. So it again set it to 901. So instead of 902, it is happening as 901. So this condition is nothing but a race condition. You must have seen this in other programming languages, right? Yes. So how can we solve this in Go? So in Go, we like for WaitGroup, we use this sync package, right? The same package also has a method called as Mutex. Okay, structure called as Mutex. So which provides a way to like handle this. So there is a method. So let's just first create the variable. Okay. Let's just create a variable of structure, which is mutex. Let's say mu sync dot mutex. Okay. So this variable now this increment needs to read it. So this will also reference by reference. So we'll pass this as reference. Okay. So basically this will hold a lock. So there is a method nu.lock, so which will lock this resource till from some other Goroutines trying to access it. Okay, so you can just unlock it once you are done. Okay, so this is very simple way. So you just need to create this variable and pass to your Goroutine so that so this can be maintained as atomic operation. So whenever we acquire lock, one Goroutine acquires lock, then other will wait. Okay, so this is how it is. What has happened? Is there anything wrong with it?
Asterisk sign is
And-
wrong.
Star. You guys are good. Yeah. Okay, so see, now always this will return 1000. So now there wouldn't be any race condition. So this is how we can like handle this race condition using Go. Okay, so what this is doing? So this is blocking for other Goroutine to like to execute, right? Next lines. So this, once you reach this, so this will block and this will go to next line, right? Once let's say the first Goroutine is trying to access, first this will acquire lock and move forward. As no other Goroutine has acquired this lock, it is allowed to go ahead, right? And then it will increment till it is performing this operation. Other Goroutine tries to acquire it, but it will not be allowed because this is already acquired, right? So this is how it works, sync and mutex. You just need to call lock and unlock. Okay. Any questions on this? Okay, so this is as simple as that. Okay, so the definition is mutex is used to provide locking mechanism to ensure that only one Goroutine is running the critical section. Critical section is nothing but where we are updating that counter. Okay. Okay, so there is one way you can identify race conditions in your code in Go. Okay, let's just copy that code in our. Okay, I already have that, I think. Okay, this is the program which we had in the Go play, right? So this is the same. This is the race condition which we have. So we can detect it by just running it using one flag. Go run. I think race may not go. If you run it. What it is doing? X. Where did I print X? X is counter. So why it is printing true? Oh, sorry, I ran this wrong program. I had created this race.go. So if I try to run with race, then it will automatically identify there is a race condition. So this is the command you can use like whenever you write your code. If you if you want to check whether your code has race condition or not, you can use using this race flag. This automatically detects whether your code has race or not, race condition or not. Okay, is this fine?
So like if we're using race solve all the conditions correctly, or should we prefer using mutex?
No, this is just a way to check. So if you want to solve it, then you need to use mutex only.
Okay. No, I think because it gave 1000, that's like the answer. It gave 1000, that's why I was confused.
It was also giving warning, right? For that, when I am running it here, it is giving 1000. Not sure, but why? But yeah, it can change anytime.
Okay, sure.
But you can check it. So ideally, when you are running it here, if I run without race, okay, this will give a different outputs. 983. This will be 9. Okay. Sometimes it happens that like you don't run it multiple times. You think that it will work. So there is one quick check you can do, like you can just run it with race instead of normal check. So that will tell you like whether your code has race condition or not.
Okay.
Okay, so this is about sync and mutex. So the same problem can be solved with one more way. So yeah, we saw unbuffered channel, right? Sorry, buffered channel. What was that? Can someone tell me? But how it was different from normal channel? We just saw it, right? Before some time.
It blocks if there are more than limit, like messages coming more than limit.
Yeah. So how to define that buffered channel? Let's say BCH. Okay. How to define it?
Take channel and just provide an limit.
Okay. Let's say 1. Okay. Instead of using this, I can use this buffered channel as well to like avoid this like race condition. Okay, I'll do it. You guys tell me how this is working. Okay. I'll just remove this mutex and I'll just pass. What was it? It was type integer of BCH, CH of channel end, wait group. So now I'll not use this. Okay. Writing and then I'm ready. Okay. So this will also work the same way. How can you guys tell me? BCH. So we learned this concept just before some time. So that's why I'm asking. Can someone explain why this will also work?
The channel requires some kind of lock as well. So it's similar to mutex. It works the same way.
No.
So
Channel has a capacity of, so it will be waiting for that only, and till that it executes, it will avoid the race condition.
Correct. So basically this channel we created, buffered channel, had size capacity of 1. Okay. So what is the like principle of buffered channel when it will start blocking?
it has to be filled.
When one value has been filled in that, then it will start blocking.
Correct. So in this example, when we launch this Goroutine, so first Goroutine will write. So this will allow to write atomically, right? Channel has atomic operation, right? It can allow to write only one, right? So one channel, one Goroutine will be able to write it and it will go to next line. Till first Goroutine, it will not block. But as this Goroutine has already, like this channel is already full with one entry, so this will go to next. But when another Goroutine trying to write on the same channel which is already full, it will block, right? Buffer channel will block for writing when it is full. So whenever we are listening, it is always blocking, but whenever we are writing, so buffered channel is blocking when it is full. Unbuffered channel is write and read, both are blocking always. Is this clear? Unbuffered channel are blocking while reading as well as writing. Buffered channel are blocking when it is full, after it is full. While writing and while reading, it is always blocking. Is this clear? If not, please tell me. Okay, so this is how this will also work, but mutex are basically created for the race condition handling purpose. So ideally we should use mutexes for such cases, and channels are basically used for communication between Goroutines, which we saw, like if we want to get some response from one Goroutine, then we should use channels. Is this clear? Okay. Can we say a mutex is like, yeah, we can say that, yes. You can check the implementation as well. I haven't checked it, but you can check it. It might be using the same concept inside. That's a good thing to check, by the way. Okay, so till this is clear. So what all things we saw? Can someone briefly summarize? Someone, please. Should I do it? Okay, so in the today's session, we saw first, so what is concurrency and parallelism? So how are they different? Okay, and then the basic principle behind this designing Goroutines and channels. Okay, that is, do not communicate by sharing memory. Instead, share memory by communicating. Always share memory by communication. Okay, so then we saw about like how Goroutines are different from normal threads which are being used by other programming language. Okay, and after that we saw basic syntaxes of Goroutine, like how to create a Goroutine, how to like call it, right, and then how to make it wait for to be complete, okay, using wait groups. And then we saw few miscellaneous about wait groups, right, when to call add, when to call done, when to call wait, right, how many times it should be called. Okay, and then we come to channel, how to define a channel, how data flows in the channel, out of the channel. Okay, and then we saw different like syntaxes, like when to close the channel, different types of channels, ranging over a channel. Okay, and then we saw sync and mutex, and how can we solve same problem using buffered channel. That is what we saw. Okay, is this clear to you all, or is there anything I should repeat, or do you have any questions about it? Yeah, I know these are the new concepts. You need to try it out. You need to get hands-on to it. Okay, if there are no questions, can someone like write down like no questions? Would the answer to which one? Can you please repeat? I don't remember the one.
The one where he asked like, why is the sum Goroutine executing multiple times? This one. So is it because like counter didn't update properly and
Let's see it. I also don't observe it. Okay, so we are calling this sum function. ch2 is sum function is written only once. Okay, so why this is printing twice? Let me run it again. This is somehow getting printed. Yeah, let's try to debug it. Can someone tell if anyone like observed something? I also need to check. So we are printing data int ch2. We're passing correct channel storage. We'll just get into it. The sum function.
Is it like the default, like since the for loop is running and there is no value being given, so it's taking 0 as default, while the like both the if condition is true, till then it is taking the default int value for channel 1? Is it like that since it's 0?
Yeah, I
Yeah,
think
like
the reason is because we are listening here twice. So here, like, this is called when the channel was false also, right? I think that is the one condition.
at the last
Channel
step
1 is
when
also
it's
taking blank
closed.
string.
Sorry?
Yeah. So is it like the last time the channel is being receives a message, it's like it's closed. So that's the last, like the end case, because even in channel 1 the empty string is being received. So like one extra message at the end, something like that.
No, I believe like when we started this loop, then like here case is that when we have, so this is getting
Yeah.
executed twice.
Yeah, could you also print ch1 open and ch2 open in the print statement?
Yeah,
After, yeah, I think that could help us deep a bit.
ch1 and this is ch2. Ideally we don't do such things, so that's why. Okay, ch2 open, ch2 open. Let's just run it. Nothing happening. It print multiple times. Yes. Okay, this time. Acha, okay. See this. Once the channel got closed, then also it got executed. Right?
So like,
Can
does
we-
it receive a message that it's closed? Like, is that a call to the channel message?
Yes.
Like that could be something maybe.
Yes, yes. When it is closing, that time also it is sending this message closed. So we are listening to this. If we don't really...
Can we put the if condition in the starting of the for loop?
Okay. But this value is anyway set here itself. Okay. So this will not affect. No, this is not right because this is happening. This should be checked after the values, current values are set. Current values are set here. Right.
Is it because like we are actually reading from the channel, trying to find it is open or not, and then we're also
that's
printing
right.
that part. So we can put an if
we
condition.
If here, if channel is open, then only that is
Correct.
one condition which we have. Yes, that's true. In case of like this is getting executed multiple times right now. See, earlier it was getting executed only once because this is also something which is always returned. So this case is wrong. I think if there is only one value, then this will be executed only once. We are using this twice, so that's why it is getting executed. So this value is also present, right? Case check some value. So there are two values here, so that's why it is this case is being getting matched.
Like
In
we
case
will.
of this, so here there is only one value, so that only one value is available whenever there is a write on channel. So that's why if we write, like we just read this only value, not the channel open or not, in that case, like this will be executed only once.
So is there like a way to check if the channel's open or not without receiving the value?
No. No, there is no.
Like if the channel is closed, then we can avoid printing the values, right?
I think there should be some way. Okay. I'll let you guys know on the Slack. Is that fine? For this question? Question is valid, yes, of course. What is this case
I
time?
have one question. Like in the mutex one, do we need to destroy the mutex after using it?
No, we just need to unlock it.
Like
we cannot forget.
after unlocking, we destroy the mutex also. Do we need to do that here also? Like after the Goroutine has been called, like whenever we create threads in C, after the threads has been called, destroy the mutex which we had created. So do we do that here as well?
No. Nothing is
Like-
required. You just need to lock and unlock.
Lock and unlock, that is fine. This is not that code, I think.
Yeah, Go will automatically garbage collect that part.
Okay.
Yeah. Garbage collection is done automatically by Go, so we do not need to handle it. So when you unlock it, that time itself, like this is done. So if you want to use it again, you need to lock it again. Okay, that was a good question. That I didn't know we need to destroy some other language. Okay. Any other questions? Okay, I just had one thing actually to show you guys, like how this. Okay, there is a analogy video I have, like which explains about how. On this, which explains how this runtime works. Like so, for other programming language, they use operating system threads. But in case of Go, we have runtime, which is written in Go. So how that works, this is really explained like very well in this video. So I just wanted to show you guys this. So yeah, let's start this. Okay.
Super simple. Put the keyword Go in front of a function call, and the function becomes a Go routine.
Is volume clear to you guys for this video? Hello?
Yes.
Okay.
And executes independently of the rest of the code. But then, what are Go routines exactly? Are they system threads or something else? Indeed, Go routines are something much more lightweight than system threads. To explain how Go routines, system threads, and CPU cores are related to each other, I want to make use of an analogy. This is a little gopher chef. This chef represents a Go routine. A chef needs something to cook with, so let's give our gopher a pan. The pan represents a system thread. A thread provides a context of execution to a Go routine. To actually cook something, the pan needs some heat. So we put it on a stove, which represents a logical CPU. A logical CPU is a virtual CPU core, which can either be a single CPU core, or, if the physical CPU supports hyperthreading, a single hardware thread. The stove can be the only one or one of many in a large kitchen. The kitchen represents a physical CPU.
Is this clear to you guys? Physical CPU means like our machine has multiple cores, right? So this is nothing but a physical CPU.
The kitchen represents a physical CPU.
Cores. Okay. And
This
each
analogy
physical CPU will have logical CPUs.
on the screen, I will continue to talk in terms of logical CPUs, threads, and Go routines. For the sake of brevity, please also allow me to make a few simplifications by leaving out details that are not strictly necessary to know from the perspective of a programmer. The goal is to get a general feeling about the behavior of Go routines. On a given logical CPU, there can be exactly one system thread and one running Go routine. A thread, however, can have a number of runnable Go routines assigned. They are waiting in a local queue for their turn. Occasionally, the running Go routine gives way to one of the waiting Go routines, for example, when it has to wait on a channel to deliver some data. This switch is quite efficient since it happens local to the logical CPU. Sometimes, Go routines need to do system calls, for example, to write data to a file. Typically, a system call blocks the entire thread. Therefore, both the Go routine and the thread are getting parked while the operating system processes the call, and another thread is either unparked or created and takes over the local queue. Then one of the runnable Goroutines in the local queue can take over. When the system call returns, the Goroutine becomes runnable again and gets reassigned to a local queue. The parked thread remains parked to be available for future system calls. There is an exception, however. Some types of system calls have their own thread running, like, for example, the network caller that processes network communication. In this case, the Goroutine that makes the system call is assigned over to the existing thread and no thread parking is necessary. While our program runs, Goroutines eventually finish their work and exit. When the local queue of a running thread becomes empty, the system looks for runnable Goroutines in one of the other local queues and takes half of the queue over. This way, the system avoids that some logical CPUs idle around while others are overloaded with work. This step is the reason why the Go scheduler is also called the work stealing scheduler. If there is no work to steal from other local queues, the system looks into the global queue. The global queue contains runnable Goroutines that have not yet been assigned to a local queue. This way, the system can keep the work balanced across all virtual cores. I hope the Gopher chefs were able to give you a general idea about how Goroutines are managed for you in the background, and how the scheduler goes great lengths to maximize CPU capacity with minimal overhead. And that's it for today's QuickBit episode.
Something understood or nothing understood? Hello? Yeah, I know this is like first time when you see, you don't get it. But I think I'll share this with you guys, the PPT itself, so you can have a look at it. Yeah. If you have any questions, you can ask it in the doubt session, as well as you can ping me on the Slack, so I'll be able to answer it. If you have questions right now about this or anything else, we can discuss. Okay, code snippet is there in the slides itself. You can have a look. You can play around with it as well. Okay. So guys, you need to practice this. I think, yeah, this is the first time you are using channels, so you need to get hands-on to it. Okay, so yeah, I'm done from my side. I hope there are no questions right now. Okay, yeah, thank you.
Thank you, Ashwini. Thank you so much.
Thank you.